to work on removeMin problem. So this is our heap. And please pay attention to this underlying array as well, because this is actually how code will be handling removeMin. So let's say we call removeMin on this given heap. What would happen? So what we first need to question is, how can we know that for sure that this two needs to be pop out, but what's going to replace the value, right? So when we remove the overall root and replace the last element of the array, right? And it also logically makes a lot of sense because we know that this is the safest item to move. Let's say we imagine that this 5 was replacing or so, then we will need to, things will be much more complicated, that we need to reorder these other children and such. So what we can do is we can simply bring the most right item, which is just the, in this graphic example, it would be the most right tree at the bottom level. But on the array, you can think of it just the element at the very last index will be replacing the overall root. So you see this was actually crossed out. And then now 9 will be replacing that. But we know that for sure that the heap invariant is actually broken now. So we should do either percolate up or percolate down. But you don't even need to memorize those things. If you look at this drawing, you can immediately tell that it's at the top. So we do need to go down, calling percolate down calls. So in order to figure out what's happening, we need to check, okay, is 9 less than or equal to 5? But that's not true, right? The question that I just asked is essentially the invariant of minimum heap, min heap. So that it actually, this hasn't violated. So we can say remove the overall root and replace with the last element of the array has broken the invariant due to this reason. So now we need to actually swap them. So what's going to happen is literally swapping those 5 and 9. But like we have worked before, similar to inserting the item where we have to percolate up, when we percolate down, we also need to call this multiple times, possibly, not always, but possibly multiple times until it gets a right spot. So we need to keep calling it. And then say when 8 is less than 9, but that is not true, right? Because 9 is actually now less than or equal to 8. So then we know that we broke the invariance. So now we can just simply swap them. So look at this array carefully too. This 8 and 9 was swapped. And now we don't have any children, so we don't have to worry about it. And we are indeed 9 is indeed at the correct spot, and we have a valid heap as well. So you can think of like scenarios where there are multiple removeMin is being called, but then this percolate down call will be called every time as well. And potentially for multiple percolate down will call for one removeMin. So please keep that in mind as you're working through this problem.